Hey, hello there, welcome to CS School channel. In this video we are going to solve majority elements 2 problem. As the name suggests, this problem is dependent on majority element 1 problem. So do check out that video if you haven't. The link is in the description. Also the lead code link of this problem is also in the description. So try to solve it on your own, and if you couldn't solve it, come back to this video. So let's look at the problem statement, which is also shown on the screen. So given an integer array of size n, we need to find all the elements which appear more than n by 3 times. So just below that we have been shown some inputs and outputs. So the first input is array with the elements 3, 2, 3. So what is the length of the array? The length of the array is 3, right? Divide 3 by 3, we get 1. Okay, so we need to find all the elements which appear more than 1 times. Okay, so 3 is appearing 2 times, 2 is appearing only 1 time. So we need to return array of 3 as the output. Similarly, take an input with array of 1 element. So the length of the array is 1. Divide 1 by 3, we get 0 point something. So we need to take floor of that, which is 0. And then we need to find all the elements which appear more than 0 number of times, which is this 1. It is appearing 1 time. So we need to return array with the element 1. Similarly, take this array. The elements of the array are 1, 2, 1, 2, 3, 3, 2. Okay, so the length of the array is 8. Divide 8 by 3, we get 2 point something. Okay, so you need to take floor of that, which is 2, and you need to find all the elements which appear more than 2 times. So 1 is appearing 2 times, 2 is appearing 3 times, 3 is appearing 3 times, right? So we need to return array of 2 and 3 as the output. So hope you are clear with the problem and some of the sample inputs and outputs. So now let's look at the first approach, which is the brute force approach for solving this problem. In this approach, we will maintain 2 for loops. The first one will go over all the elements, and the second one will calculate the number of occurrence of a particular element. Okay, so basically we will start with 1. We will count how many occurrences of 1 there are in this array. Okay, so 1 has 2 occurrences. Okay, then we will go to this 2. We will calculate the number of occurrences. 2 has 3 occurrences, right? Similarly, we will go to this 1 again. We will count the number of occurrences. Then we will go to this 2. Then we will go to this 3. So we will have 1 with 2 occurrences, 2 with 3 occurrences, and 3 with 3 occurrences. Okay, and then we will just list down which elements has more than n by 3 number of occurrences. Okay, so currently we have 2 and 3 with more than n by 3 number of occurrences. Okay, so that's what we will return in the result. So what's the time and space complexity for this solution? Well, we need to use 2 for loops, right? So the time complexity becomes O of n square. And what's the space complexity? As we are not using any extra space, the space complexity becomes O of 1. Now let's look at another solution which uses hash map. Okay, so in this solution, what we will do, we will create an empty hash map, and then we will iterate over all the elements in this array, and we will count the frequencies of each element, and we will store that frequency in the hash map. Okay, so initially the hash map will be empty. Then we will encounter 1. So we will write 1 in the hash map with the frequency as 1. Then we will encounter 2. As 2 is not there in the hash map, we will write 2 with the frequency as 1. Then we encounter 1 again, so we will increment the frequency of 1. Okay, then we encounter 2 again, so we will increment the count of 2. Okay, then we encounter 3. As 3 is not present in the hash map, we need to make an entry for 3 with the count as 1. Then we encounter another 3, so we need to increase the count of 3. Okay, and then we encounter this 3, so let's increment the count again, and then we encounter the last 2, so let's increment the count of 2 again. Okay, so 1 has count 2, 2 has 3, and 3 has 3. Then we need to find which are the elements which occur more than n by 3 times. So in this case, 2 and 3 are the elements which occur more than n by 3 times, so we need to return them in the final response. So what's the time and space complexity for this solution? Well, we are iterating over array only once, so the time complexity becomes O of n, right? And what's the space complexity? Well, as we are using this hash map as an extra space, and it can have up to n number of elements, the space complexity becomes O of n. So hope you got this approach. So in the last approach using hash map, we have used some extra O of n space. Now let's try to eliminate that space using Moore's voting algorithm. So we have seen this algorithm in the previous problem, but in this problem we need to modify that algorithm a little bit so that it fits to your use case. So to use this algorithm, you need to actually figure out one thing, is that there can be no greater than 2 elements in the array with majority. Okay, So as one element is appearing more than n by 3 times, only two elements can appear more than n by 3 times. So in the resultant array, more than two elements cannot be there. So if you identify this pattern, you can easily modify the existing Moore's algorithm to fit to this use case. So let's look at the algorithm and then we will go to the step-by-step execution of this algorithm. So we are given an input array 2 2 3 1 1 2 1. Okay, in the step 1, I will be 0, count 1 will be 0, count 2 will be 0, first will be -1 and second will be -1. Now we are considering this 2. So now we check if array of I is equal to first. Array of I is 2, first it is -1, so that's not the case, right? Then we check if array of I is equal to second. Well, second is -1 and array of I is 2, so that's not the case either. Then we check if count 1 is equal to 0. Well, the value of count 1 is 0, right? So in that case, we assign first is equal to array of I, so first becomes 2, right? So first has become 2 and we increment the count to 1. Okay, so count 1 becomes 1. Okay, count 2 is still 0 and second is still -1. So we are done with this step. Now we are incrementing I to this 2. Okay, so in this step, what will happen? We will again check if array of I is equal to first. Is that the case? Yes, array of I is 2 and first is also 2. So in this step, we increment the count 1. So now count 1 becomes 2, count 2 is 0, first is 2, second is -1. So we are done with this step. Now let's increment the I again. Okay, now the element which we are considering is 3. Okay, now we check if array of I is equal to first. What is the first? The value of first is 2, array of I is 3. That's not the case, right? Then we check if array of I is equal to second. Well, array of I is 3 and second is -1. Well, that's not the case either. Then we check if count 1 is equal to 0. Well, the value of count 1 is 2. So we jump to the next else if condition. Okay, we check count 2 is equal to 0. Well, this is the case, right? Count 2 is 0 currently. Okay, so what we will do in this case, we will assign second with array of I. So second becomes 3, right? So that's what we have done. We have assigned value 3 to the second. Okay, and then we have initialized count 2 with 1. So count 2 becomes 1. So we are done with this step. Now we increment I again. Then again we check if array of I is equal to first. Is that the case? No, array of I is 1, first is 2. Okay, then we check if array of I is equal to second. Well, array of I is 1 and the value of second is 3, right? So that's not the case either. Then we check if count 1 is equal to 0. No, that's not the case. Count 2 is equal to 0. Well, the value of count 2 is 1, right? So this is not the case either. Then what we will do? We will decrement count 1 and decrement count 2. So our count 1 was 2, right? So it is decremented to count 1 and our count 2 was 1. So it is decremented to 0. So we are done with this step, right? So now let's consider this 1. Okay, again we go to this if condition. We check if array of I is equal to first. Well, array of I is 1 and the value of first is 2, right? So this condition is not satisfying. Then we check if array of I is equal to second. Well, array of I is 1 and value of second is 3, right? So this condition is not satisfying either. Then we check if count 1 is equal to 0. Well, the value of count 1 is 1, right? Then we check if count 2 is equal to 0. Well, the value of count 2 is now 0, right? So in this case, we assign second with the value of array of I. So second becomes 1, right? And we set count 2 to 1. Now count 1 is 1, count 2 is 1, first is 2 and second is 1. Then we go to this next 2. Okay, we check if array of I is equal to first. Well, array of I is 2 and first is 2, right? So we increment the count 1. Now the count 1 becomes 2 and rest will remain as it is. Okay, so we are done with this step. Now let's look at this final one. Then we check if array of I is equal to first, right? This is not the case. Array of I is 1 and first is 2, right? So we go to this else if condition. Then we check if array of I is equal to second. Array of I is 1 and value of second is 1, right? So we increment the count 2. Then our count 2 becomes 2 and the rest of the values will remain as it is. And this way we are done with processing the array. And then we will check if the value we have selected for the first and second are actually appearing more than n by 3 times. Okay. So if that's the case, we will return first and second in the output array. Otherwise, we will return the empty array. So hope you got the iteration of the algorithm. Now let me give you intuition like why this algorithm works. So count1 is counting how many times first is occurring in the array. Now there can be never a case where count1 becomes negative because first is appearing more than n by 3 times, right? Similarly, count2 can never become negative because second is appearing more than n by 3 times. Okay, as in the last problem we have this intuition, same intuition applies for this algorithm as well. So now let's look at the C++ code for this algorithm. So we need to complete this majority element function, so which takes vector of integer as an input and which expects vector of integer as an output. Okay, so as per the algorithm, we have initialized first with -1, second with -1, and we have created two counters to count the number of occurrences of first and second. Okay, then we have written a for loop which will go over all the elements in the array, and as we have seen in the algorithm, we have checked if x is equal to first. If that's the case, we have incremented the count. Then we have checked if x is equal to second. If that's the case, then we have incremented count to. If either of these conditions are not satisfying, we are checking if count1 is equal to 0. If that's the case, we are initializing first with x and we are setting count1 with 1. Okay, if that's not the case, we are then checking if count2 is equal to 0. If yes, we are setting second with x and we are initializing count2 with 1. If any of this condition is not getting satisfied, we are decrementing count1 and count2. And at the end, what we have done, we have actually checked whether each of the element that we have selected is occurring more than n by 3 times. So we have initialized count1 with 0, count2 with 0, and then we have run a for loop over the elements in the array. And then what we are doing, we are just incrementing count1 if we are encountering first and incrementing count2 if we are encountering second. And at the end, we are checking if count1 is occurring n by 3 times. Then we are pushing first in the response array, and also we are checking if count2 is occurring more than n by 3 times. If that's the case, we are pushing second in the response array, and at the end we are returning the response. So hope you got the C++ solution for this problem. Now let's run this code. For running this code, I have written a main function which calls majority element function with the vector p. Okay, and the response which we are getting, we are printing that response using for loop. Okay, so now let's run this code. For running this code, I will first compile it and then run it. So we are getting 2 and 1 as output, which are our majority elements. So what is the time and space complexity of this algorithm? Well, we are just running two for loops which are kind of adjacent to each other. The time complexity becomes O of n. Okay, and what's the space complexity? As we are not using any extra space, the space complexity becomes O of 1. So hope you got the problem and its possible solution. If you have any doubt, please ask me in the comment section. I'll be more than happy to help you. We will be making more such videos in the future, so do subscribe to our channel. So hope to see you in future videos.